Hello, I'm teacher Ivan from Wunna Educational Services. I welcome you to our first lesson in A-level physics, that is majorly paper 1, where we shall be discussing all the 3 branches that make up physics 1, and each branch is given a section. So we look at mechanics, that is section A. We shall also look at heat and thermodynamics, that is section B, and finalize with the modern physics in section C. So we have started with the section A, which talks about mechanics, and our first chapter in this is dimensions of a physical quantity. When we talk about dimensions of a physical quantity, we simply refer to the way a derived quantity is related to the 3 major fundamental quantities of length, mass, and time. So we shall be deriving the relationship between a derived quantity and these 3 major fundamental quantities. The symbol for dimension is given by that type of brackets. So if we are to derive the dimensions of a quantity like a density, we must put density in these brackets to show that we are deriving its dimensions. So let us look at the examples of the dimensions of a physical quantity. So let us derive these dimensions together. Area. We know that area is given as a length squared. Or, for instance, when we talk about particular shapes, the area of a square is a side squared, but side is length. The area of a rectangle is length times width, but they are both length. So that's why we said that area is given as a length squared, and therefore the dimensions of area will be length squared, since length is a fundamental quantity. Number 2, we are looking at the dimensions of density. We know that density rho is given by mass over volume. So that gives us the dimensions of density as the dimensions of mass over the dimensions of volume. But dimensions of mass, since mass is already a fundamental quantity, so it is capital M. Then the dimensions of volume, remember volume is length cubed, so this one is length cubed. That gives us the dimensions of density, and therefore we shall conclude by saying that dimensions of density equal to mass per length cubed. So that is how we get the dimensions of density. In number 3, we are looking at dimensions of acceleration. From the definition of acceleration, which is the rate of change of velocity, we note that acceleration is given by v over time. So if we are to get the dimensions of acceleration, then we must get the dimensions of velocity over dimensions of time. But still, velocity is given by displacement over time. Displacement is length, so that gives us length per time. from the formula for velocity, which is displacement over time. Therefore, we shall come up with length per time, since displacement is length, then over time. This is the dimension of time. So, which gives us a conclusion that the dimensions of acceleration equals to length per time squared. Because when you take this one up, it becomes -1 minus 1, which gives us length per time squared. So that is the dimensions of acceleration. And lastly, let us look at the dimensions of pressure. From the definition of pressure, which is force over area, therefore, that means that the dimensions of pressure will be given by dimensions of force over dimensions of area. And remember, force is mass times acceleration. And so, mass is already a fundamental quantity. So we represent its dimensions by capital M. And we have already defined the dimensions of acceleration. So that gives us force as mass times length per t squared. Those are the dimensions of force. Over area, which is length squared. So we shall get the dimensions of pressure as when we apply indices, this one goes up. This one is already power 1, so we take away 2. And thus gives us the dimensions of pressure as per L per t squared. So that is how we derive dimensions of a physical quantity. Otherwise, that has been our introduction to A-level physics, paper 1. Otherwise, I hope to see you again. Please don't forget to subscribe and hit the bell such that you get notified whenever we have a new video for you. Otherwise, we are Wunna Educational Services, your learning partners, ready to walk your academic journey with you. Please trust us and you get assured of excellence. I'm Teacher Ivan. See you next time.